Hi everyone, welcome back. So in this video, we're going to talk about functions with array parameters. Functions with array parameters. And this, when we're talking about parameters, remember that's inputs into a function, okay? So how do we pass arrays into a function, and how do we do it being mindful of best practices, right? How to keep the code organized, how to prevent problems, how to prevent bugs, okay? Now, going into this discussion, it's important to rehash some things that we talked about related to functions when we were first introducing this topic. Okay, and if you remember a previous video, we talked about how functions should be treated like a black box. Okay, black box where we have input coming in. Okay, it does its magic, it does its thing, it performs its functionality, and we have output coming out. Okay, now the key thing when we talk about a black box is somebody using a function should not need to know how the function works. Okay, somebody using a function should not need to know what the function's doing inside to make that output. They need to understand what it's doing in terms of like what action it's performing. Okay, but don't have to know all the implementation details. Okay, now an important thing to note is one thing we don't want to have happen in this case, okay, is we don't want the function to be going and changing all sorts of random unpredictable things. Okay, so we don't want the function to be changing variables and other pieces of information outside of its desired output. Okay, so you think about it, right? We looked at it, we introduced this topic, we talked about square root functions, okay? And you know that the input's pretty straightforward, the expected behavior is pretty straightforward. The actual computational logic for performing the square root is not needed to be known for somebody to use the square root function. However, there's an assumption if you're using a square root function, right, that you're not going to be changing all sorts of wild information outside of the black box, right? You're not just changing random things and stuff all over the code. Because that would make it really, really hard. It wouldn't really be a usable thing to use, right? Because you wouldn't know if you're going to have things break on you, okay? So now I bring that up because when we talked about arrays being passed into functions, okay, we discussed how arrays are effectively passed by pointer, okay? They're passed by pointer, which means it's a bit dangerous in the fact that things can be changed inside of the function in ways that are kind of breaking that kind of quote unquote like golden rule of not changing kind of random stuff or even changing the own input. Okay, so for instance, if we go back to the square root function, right, we would expect here that I could do something like using a square root function. If I could be able to do something like int, right, x, or actually let's make it a double, right? Double x equals, say, 9, right? And then maybe I have double y equals the square root of x, okay, calling the square root function. There's an assumption here, right, that x does not change, okay? X does not change, okay? Makes sense, right? Now, I bring that up because that assumption can break down in the context of passing in arrays and strings, okay? Because of the fact that they're passed by pointer, all right? So let's look at this example here, all right? And the key thing I'm going to point out, I'm going to draw it and make some room here in a second so I can draw something to illustrate what's going on in this example. But notice that the key thing to point out is how this value here got edited, okay? We initialized it initially to 1, okay? And this is like a little stupid dumb function up here. all it did is it changed that value to 55. Now that looks odd, right? Because the function doesn't return anything. Okay, why would that output here outside of that function scope, okay, change that to 55? Right. So that's confusing. Okay, and let's illustrate what's going on, and it's very important understanding what pass by pointer means to understand why we are getting that. So let's draw it. Okay, so we've got our main function scope. And we've got here, we have size is 5, okay? And then we have our array A. And remember, array is a pointer. It points to the location in memory that's storing the beginning of the array, okay? Which is set to 1, 3, 5, 7, and 2, okay? And then we have the foo function scope. Okay, that's a common fake name for a function that's used in computing going, way back for decades. As a kind of a side note. Okay. And in the foo function scope, okay, we have array. Okay, we called it array here. And that is a pointer. Remember, it's a pointer back to the original. We don't make a copy. We point to the original. Okay. And so we have a copy of size, which is 5. Okay. So because size is passed by value, it's an integer, right? It's not an array. Okay. It's a integer. It's a data primitive. So we're going to make a copy of it. Arrays are passed by pointer. We don't make a copy. We just point to the original. Okay. So what happens is inside of the foo function, right, when we go ahead and change this location to value 55, okay, we've changed that outside of the main, it was edited outside the main function scope, and we changed the original input data. So that this way when we print out A, we're actually going to print out 55, 3, 5, 7, and 2. Okay, so this breaks a rule, right, of how treating things like a black box. What effectively we're doing, right, would be effective. It was kind of similar concept where if we did double x equals 9 and then double y equals the square root of x, that somehow x changed, right? That's kind of equivalent to that, although the reason this happens in this case is because it's passed by pointer which is always the case when we're using arrays and strings, okay? So I'm going to show you a couple, like how we can address this, okay? One thing we can do, right, is we could make the array, we can make it read only, okay, inside of the function scope, okay? Inside of the function scope. That prevents the function, right, in the body of the function, this prevents ever writing to the array, okay? The array is effectively read only. A big part of what you're doing there is you're preventing the programmer from making a mistake, okay? From accidentally changing that array when they're not supposed to. So let's look at this example. Let's actually trace what it's doing, and so that we can kind of understand the logic a bit. And then we'll do one that where we actually see what happens if we don't do this. Okay, so keep in mind, right? So let's talk a little bit about what this function is supposed to do. This one's called find integer. The goal of this function is to, if we have an array, okay, I'll just make up some values here. Okay, we have an array, and we also have a key, which is what we're searching for. So let's imagine the key is 7. Okay, what this function's doing is it's walking through the array, looking to see if it finds that key somewhere. in this case 7, okay, which is passed in. If it's found, it tells you the location of where it was found. Okay, in this case, it was index 2. So this is the value that's returned is 2. Okay, if it's not found, it returns -1, saying, hey, I couldn't find, it's not in the array. Okay, so that's what that function's doing. And I want to point out, right, that this function has no reason to ever edit the array. Okay, if you're searching for something, there's no reason you should ever have to edit the original data. Okay, so that's an important thing to keep in mind. So when we think of what is the proper interface for this function, okay, it should the proper interface should enforce a read-only access to that array. There's no reason it should ever be edited. So we're going to enforce that rule. If you add this constant here, you've now enforced that it cannot be accidentally edited. Okay. All right. And then we can trace this just to kind of get a better sense of what's going on again, looking at memory, how things are being stored, and function scopes. And if we do that, let's go ahead and do that, right, is we've got our main function scope here that I'm going to draw up here. Okay, we've got size being 5. We've got a key being, in this case, 8. Okay, I'm looking down here to define that. Okay, and then we have array A. Okay, and remember, all arrays are always pointers, and this points to value 2, array 2, 3, 8, 1, and 7. Okay, and then in the find integer, okay, we have array, and I want to point out here, so we know array is right, all arrays are really pointing to the location in memory where it's stored, is I want to indicate here that because this has the word constant here, okay, inside of the find int function scope, this is a read-only access to that data. Okay, read-only access. So we cannot change anything inside of this function scope. All right. We have pass by value for size. So we have a copy of size being 5 and also key being 8. Okay, just happen to have the same names. Although one has size has a different, one is capitalized and one's lowercase, but it doesn't matter. They're different variables anyway because they're in different scopes. Okay, and so when we go through, we run this logic here, right? Effectively what happens is we walk through looking for a key, which the key is 8, and we're going to go ahead and we're going to return this location, which is location 2, okay? And one thing I didn't point out here is we also have the index ID x, which is in the main function scope. So when we return 2, okay, index, which is in the main scope, is going to be set to 2. Okay. All right. So a couple key things to recap on this, right? If a function should only have read access to an array, okay, make it constant. Okay, make it constant. Okay. We will talk about in a subsequent video of looking at returning arrays and some of the difficulties with that. There's actually a lot of nuances with that, and so that's going to be something that we'll have to do in multiple steps. Some of it requires looking at how memory is allocated, and that's a whole discussion for another day. Okay. All right. The other thing I want to point out here, okay, when we talk about passing in arrays, is that we should always pass in the size of an array. Okay. The reason is, remember, we're only passing in a pointer. Okay. When we array here, right, points to a location in memory. So when we think of memory, think of a memory as in and of itself as being like a gigantic array. Okay. We have a pointer that points to where the array begins, effectively. Right, so we'll say we got a bunch of values here and so on. Remember, though, that we need to know where to stop. Okay? Size lets us know, okay, when we should stop continuing to read. Right. Otherwise, you don't know how long you know where the array begins with the array pointer. You don't know where it ends unless you know the size of the array. So this is an important parameter to have. Okay. Now with strings, we actually don't need that, right? We don't need that with strings, and the reason we don't need that with strings has to do with the fact that unlike arrays, we actually do know where the string stops. Okay. Because if we do the same drawing for strings, okay, now a string is an array, it's a character array. However, there's a convention that the null terminator indicates where to stop. Okay, so for strings, you actually don't need to know. You don't have to pass in the size. You can just pass in the actual string itself, because you can find the size using the null terminator. Okay, or effectively using the string library, doing string length. Okay, that will give you the size, and it finds the size by doing the same thing that we just looked at a moment ago, where we actually run through the array looking for this terminator. Okay. All right, so we'll stop there. Right, we still haven't looked at how to properly return arrays. Okay, but we'll do that in a following video. Thanks for watching, and feel free to reach out to me if you have any questions on any of these topics.